why steel should gain ground in construction. That everybody is telling today that steel is gaining ground because of lack of skilled workforce, which is one of the major causes of concern. But still it is very difficult to depart from convention. It is very difficult to convince people to change from convention. And another most important thing which clients can be convinced easily is the value engineering and buildability aspects. Nowadays we are very well sure. I am at least working on 2-3 projects simultaneously where I try to convince the client. Client wants to build 20 lakh square feet of building in 12 months in the heart of the city. And I tell him, how can you handle 100 transit mixers in night? We are permitted concreting only in the night. And you have 100 transit mixer to be handled in 10 hours in a site which doesn't have even space after excavating for the basements. This is a very common thing. So this is where the issue of buildability, which most of us ignore many times, the buildability aspects, how many transit mixers, how many boom placers you want, how many cranes you need for a given site. And steel, obviously, the dead weight of the structure or volume of the material reduces to 1/5 of the total consumption of the material. So these two will speak of value engineering. At the end, these are the steel consumption graphs. Of course, this is because steel gaining ground. I'm also happy to share that it's not only giving lectures or doing design. To promote this concept of pre-engineering in our country, I have also founded one society called Pre-Engineered Structure Society of India. And we conduct one conference every year. Next year I am conducting in Delhi to popularize this concept, because this time we chose Delhi because most of the decision makers are in Delhi and they don't want to come down. So we better go up and convince them. So these are typical pre-engineered buildings. This is a Tech Mahindra project which I am showing here, where we did a lot of work to convince the client and contractor to switch over from concrete to steel actually. This is a case where we have to build, actually this building is to be completed in 20 months, finished, starting from excavation to finish and handover. Of course, we have achieved, but with a brutal force, not engineering, not engineering. You are not able to achieve a target with 1,000 workers, okay, make it 3,000 workers. At what cost? That nobody is working out. So we did the real value engineering before decision making. In fact, as consultant, we strongly suggested that we must go for steel. Though I mentioned Jindal here, it is actually JSSL with whom we worked very closely to convince the client, and ultimately it has gone to post-tension option. But we had a lot of problems. I would not share here. The buildability aspects were ignored while taking decision to go for concrete, and we are seeing the result of it. So I want to share with you that in any project, we have to do the value engineering assessment and buildability assessment for any project. And this is another steel building which we normally complete in 3 months, these kind of projects, Decathlon. And this is also concrete structure. Yeah, this is another project we were asked to design by the AP state government, newly formed capital. For that, we were awarded with a nationwide competition to give a methodology to complete a secretariat building of the government within 90 days. 90 days from the start to finish. That means we were to be awarded the work on February 20th, and we had to hand over the building for occupancy on June 8th. That was the timeline. So March 20th to June 8th was the time we had to finish and hand over. We conceptualized everything, but later government. But there we have used steel as the option because that is the only thing. I also want to share with you, we have really completed one building, auditorium of 250 persons capacity in 60 days using steel. There, including the flooring of the auditorium we did in pre-engineering. That means if you have ever worked on an auditorium project, actually flooring is the most critical item because we do the false ceiling. We have auditorium means you have all audio visuals, everything behind the ceiling. So first you have to do the AV work, then you have to do the ceiling, and then you remove the scaffolding and do the flooring. So we have foreseen that, visualized that problem, and we had designed the pre-engineered flooring. And flooring will have the curves and steps and everything, and you have the embedded services in flooring also. So we have completely done the pre-engineering of the flooring, and the whole flooring of the auditorium was assembled in 2 days. Exactly 2 days after removal of the scaffolding. So that is the power of steel actually, buildability. When we talk about the buildability, steel is most buildable material in construction. And this is the warehouse. Again, it is a smaller project, but very interesting. And this is industrial projects. And this is a powerhouse where I want to just take, this is interesting work which we did in steel. This is a 47-meter span, that is iron, aluminum ore stacking place. The interesting thing we did here is normally you have truss in lattice and purlin in this one. Here the purlin we did it in lattice, triangular lattice structure, and the portal we did it in box section. And the client, in fact this photograph was sent by client to me saying that it is looking beautiful. You have reduced the number of lattices and confusing patterns in the structure. So this is the drawing of that. And we have also utilized the entire space in a, actually it will be stacked. The ore will be stacked through a conveyor. The above structure, this is a conveyor actually, conveyor gallery. So we have followed the slope of that and designed the portal to accommodate the maximum material, and there is no space wasted in that. These are many other structures which we did in steel, of course. This is another project which we have completed in exactly 4 months, start to finish, including design and handing over. This is for steel only. This is actually for ITC. In fact, Somasundaram must be knowing, Bovis were the project managers for that. In '99, when there was no PEB company in India, we had done completely pre-engineered structure in steel. We had tough time convincing Bovis actually at those days because there was no traditional PEB company. So Phil James was there with a list of questions, about 150 questions. Yeah, Bob Perkins also. So we had to answer all that about the buildability, safety, because this project had the highest safety requirement. The project was stopped for 2-3 days, 2-3 weeks, because in the tender we have given a regular spec for the safety, that is fall arrest belt and all. And one of the ITC director visited the site and said, how do you prevent? Okay, you arrest, but how do you prevent the fall? So we had to redraft the spec. We have changed it to holding cages, crane holding people. ITC was ready to spend more money and it was a really good thing. And we had installed in '99 itself 360-degree camera for monitoring the safety of the workers. And yeah, exactly. So we had a data logger of 7 days those days itself. Nowadays itself we are finding it difficult. So entire site construction activity was recorded for 7 days, so that if there is any accident we can retract and identify the reason. In fact, there was one injury of a thumb while doing the erection. So that was monitored back and corrected, and again safety drills were given. So this is another interesting project we did. And this is Kirby building itself, their first manufacturing plant in Hyderabad. We had the opportunity to work. The challenge here is 360 meters long shed. The crane has to run from one end to the other. The alignment. Can you ever imagine in concrete? I know some of the most important defense establishment, crane getting struck for even 100-meter long, which they have built on concrete columns. And here it is a steel structure. It's already more than 15 years old. and we don't have any compliant working of the cranes or alignment of the building. So, lot of steel structures. I'll just come to the. This is actually a 20-meter high building with a 10-meter floor where we had the machinery installed, and we didn't use the bracings because we wanted to give also, we have done the movement connections in the steel. Because many people think that steel means you get a lot of bracings and all. It's not necessary. We used all the built-up sections then itself. And the staircase, you can see the detailing we have done for the facade. Though it's an industrial building, we have completely done the glazing, and it was aesthetically utilized. These are different other industrial projects, regular industrial projects. Awesome. This is another Schneider plant in Hyderabad, which we have done. You can see including the cladding, it was all dry cladded, and it was finished with the insulated seamless roof of 45-meter long sheet with side rolling, and it is a completely air-cooled building inside. And these are some other interesting structures we did in steel only, and this is also steel rolling mill and fabrication unit. And this is a 12-meter span stadium with a cable stay actually. And we have done all the testing before erection, and the architect didn't want to see the bracing. So you can see even the truss, we designed it as a portal frame like. And this is a dome. You can see, I mean, we can never get this kind of visual effects when we do in concrete or other materials. It's a 48-meter span dome with a polycarbonate sheet, and distillery projects. And this is our bread and butter towers I keep doing. In India, I would have done about 3 lakh towers of cellular towers. The phone, now 4G also we are doing. And this is the spun concrete pole actually. And this is a steel structure and transmission we do, and tubular sections. This is another interesting thing about buildability steel again. This is a tower, you know, there is a sharing regime in cellular companies. Every cell phone companies, they have taken out the infrastructure and they took it back on leasing. So what happened is all 6 operators like Bharti, Airtel, Vodafone, Idea, all of them will share one tower. Originally, each one of them have built the towers. But later, one tower built for one operator was to be shared by 6 operators. So we have to do the retrofitting. But they don't want to disturb the ongoing operation. You know, the revenue laws, and we comply in call drops and all. So we have strengthened this tower. This is the original tower leg, and this is the additional leg. And we have introduced, just used these boards which are there in the splice, and introduced a shoe plate, and created a new splice, and strengthened, like we reinforce a fractured bone. We have reinforced the legs of the tower, and even IIT refused to certify this, and then we had got it certified by another agency. And this was done based on plastic theory actually, the strengthening method. Otherwise there was no other. So 160 towers we had strengthened within 2 months with this method. It's all prefabricated, brought to the site, and because the tower design is a standard one, we can do this kind of things. Yeah, this is we are talking about LGS sections, and thanks to our pre-engineered structure society, this is called a speed floor, which again this is JSPL product they supply in India, and you can erect the structure and concrete the floors simultaneously 2-3 levels. And this is LGS and speed floor thing. I'm sorry. Actually, we do the assessment, when we talk about value engineering of a project, there was another project which is ongoing. I thought the table is there in the presentation, it is missing. But considering the safety, quality assurance, and buildability cost, we give a score for each of the aspects and finally tell the client out of 10 points, which it is not only, when we say value engineering, it is not only the cost, direct cost. In fact, these are the days when the direct cost of material takes lesser. If we are seeing the cell phone we are ready to pay 60,000 not for the material actually. It is for the technology. Same, why not in civil engineering? Everybody questions us, what is the cost of sand, what is the cost of steel? And there is a technology in this also, and there is a risk involved. We are talking about safety, man hours and all that. So we have to insist on clients going by the value engineering method and buildability aspects. So I want to, that's what I wanted to share with you today.